Successfully deploying applications on SAP Business Technology Platform, BTP in short, is just the beginning. True value emerges when you can efficiently operate, maintain, and scale them. In this series, we will explore the different ways to do exactly that. And by the end of today's session, you will know how you can observe at depth your SAP BTP apps via SAP Cloud Logging. A very warm welcome, and thank you for joining our 5th episode of our series, Mastering Day 2 Operations in SAP BTP. I have the pleasure of having here with me Wolfgang Theilmann, Development Manager at SAP. Wolfgang heads the development of various observability services within SAP BTP. Within that scope, he leverages a long history of scientific research, but also more than 10 years of development and operational experience. Recent engagements in Open Source Software Foundation strengthen the liaison with major open source initiatives in this field. And now, without further ado, over to you, Wolfgang.
Great. Thanks a lot, Tania, for the nice introduction, and warm welcome from my side. I'm happy to present to you our solution, SAP Cloud Logging. And let's directly dive into the slides and also the stuff that we prepared for that. So, hope you can see the slides well.
Yes.
So, as already introduced by Tania, today it's about how to observe or how to monitor, you would typically say, your BTP applications in great depth. So not just from a high-level perspective, but really at great depth by making use of our service SAP Cloud Logging. This is part of the overall Day 2 operations series. You see here the different areas: security, administration, operation. Today's session is part of the management section of your own application lifecycle. And the agenda or the story I want to go with you is as shown here. So first, I want to try to give you a big picture of observability for BTP and where SAP Cloud Logging then plays its role. Then go deeper into Cloud Logging, giving you a bit of overview, the positioning and the capabilities. And then going, I guess, to the core of this session, and the core to your concern is how to observe your BTP workloads. And this part will be mainly done by a demo. I'll show you really how to observe Cloud Foundry applications, schema applications, how OpenTelemetry, I will tell more about that later, plays in here, but also how you can extend your observability solution with custom means, with custom dashboards, custom insights. After that, I will bring you on a journey from application logging, which is a service we are already offering for almost 10 years, and how you can go from that one to the next generation cloud logging, which is the focus of today, mainly by giving you insights into the so-called innovation guide, but also the migration guide. And last but not least, we'll conclude with a summary and some further information links. As usual, a disclaimer applies also to this session. So you know about the scope of this content, that it's proprietary to SAP, and about the disclosure rules. So please take that into account. And now let's go into the big picture for observability for BTP. Actually, this is already a non-trivial endeavor because there are different perspectives on how you can look at observability in terms of BTP. So I try to bring here 3 perspectives which collectively shall help you to understand the picture. The first one here is the operator perspective. So that's a slide you might have already seen at the beginning of this series, where the Cloud ALM solution has been presented. You see it here on the left-hand side. Cloud ALM is really the central observability tool for BTP, but also for overall SAP solutions. So it's there to detect problems in the first place. However, now, if you go deeper into a BTP case, you want to further analyze a problem to find an eventual root cause and a resolution. And for such things, you need local observability tools. And the prime tool we offer here in the context of BTP is SAP Cloud Logging. So this shows you the interplay of central Cloud ALM and the local observability with Cloud Logging. The next perspective is rather the developer perspective on things. So how to observe your full stack applications, which typically come with a so-called CAP Cloud Application Programming Model. So you might have heard about the SAP Developer Guide, which is the general best practice guidance on how to develop on top of BTP, but then also how to address things like observability. And within that developer guide, the already mentioned Cloud Application Programming Model is a major featured programming approach. And to have observability, detailed observability to that model and our applications developed along that model, it's clearly explained then how to use SAP Cloud Logging. There's an even very practical starting point for this, which is the so-called mission in our Discovery Center. So in Discovery Center, there are missions. And one of those missions basically is about how to implement observability in a full stack CAP application following this BTP developer guide. So this is a very detailed step-by-step mission, which tells you, okay, what kind of prerequisites you have to pay attention to, and then stepwise how you implement, set up cloud logging, bind cloud logging, do your observability stuff, instrument and stuff like that. And it even comes with a sample application that can serve as a very practical learning tool for your things. And you see here schematic architecture view how such a CAP application and its integrated observability may look like. The last perspective is rather the technical perspective. So I already mentioned briefly this notion of open telemetry, but also you used observability already years before open telemetry arrived. So this slide shall give you a little bit of, it's a simplified view, but shall give you an insight how from your applications, which are down below, for example, here, Cloud Foundry-based applications or Schema-based applications, how observability or signals data eventually reaches Cloud ALM or Cloud Logging. So the traditional ways, which have been there for years now, are these ones I show now. For Cloud Foundry, there's the Cloud Foundry logging system, which basically collects logs from the application and can propagate these to Cloud Logging. Similarly, for Schema, there's a log agent to collect logs and propagate it to Cloud Logging. But now recently, there's a new kid on the block, the already mentioned OpenTelemetry. So that's an industry standard which does support metrics, traces, and logs. And in the meantime, we have means to instrument Cloud Foundry-based applications, but also Schema-based applications in the way that they can emit OpenTelemetry compliant signals in terms of metrics, traces, logs, and from there eventually propagated to both Cloud ALM and Cloud Logging. And with that, you already see why the integration between Cloud ALM and Cloud Logging can work so nicely, because they rely on the same signal series, which is based on OpenTelemetry. So that's the third perspective I wanted to show. And so far, that's the, so to say, big picture, which hopefully is helpful. Now let's dive more deeper into what SAP Cloud Logging is about. If you only have 3 minutes left and then have to leave this session here, that's the one pager you should capture. So Cloud Logging, it's positioned as a quite comprehensive observability solution based on logs, metrics, and traces. It serves application developers and operators to analyze their BTP workloads. In regards to application logging, which is already existing for many, many years, it's positioned as the next generation observability solution and already available since more than a year, and comes now also as the success or the next generation really of application logging, which is about to be deprecated at the very moment. Last but not least, interesting to know is below or behind Cloud Logging, there's a very powerful open source initiative, which is called OpenSearch. So this is the core engine that we use, and I will get back to that in more detail later. Now looking at the key capabilities of Cloud Logging. First and foremost, there are capabilities which really make cloud logging unique compared to all the observability solutions you might find elsewhere in the market, which is the dedicated support for BTP runtimes, mainly Cloud Foundry and Kyma. Perhaps in future also ABAP will join the arena here. And what is so special about this is that we take really care to support very smooth ingestion of data from those runtimes and then bring them into the service and provide pre-built analytical dashboards so that you find very good starting point to analyze your Cloud Foundry or Kyma workloads and get immediately a great insight into your applications. Furthermore, there are a couple of capabilities which are in particular relevant in comparison to the predecessor application logging. First and foremost, we already mentioned support for OpenTelemetry. So the service now not only supports logs, but also metrics, traces, and even other protocols. And then second, there are very advanced data processing and customization possibilities. You can do alerting on your data. You can do anomaly detection. You can configure the structure of your data, how you want to get it stored and managed, and can also decide for the first time now on the retention of your data. So how long you want to keep that data. And last but not least, there are rich means to customize your content. So to create own visualizations or own roll-up jobs and stuff like that. And more security topic, to do fine-grained access management on your data. So these are all capabilities which go clearly beyond application logging, and here with the runtime support clearly beyond what the marketing outside offers. So that's the one-page overview. Now I still have a few minutes left, so let's dive into a few more details. So starting with the positioning. Persona, I already mentioned, application developers and operators. The use cases are very, very widespread where you can use cloud logging. It's basically for kind of analysis and automated processing of all kinds of observability data. So you can use it to do performance analysis, to analyze for errors, to understand better the resource consumption of your applications, or to look into communication flows, so-called traces. You can use it to understand the usage of your application, so how customers make use of it, or a wide variety of other observability characteristics. Workload-wise, already mentioned, Cloud Foundry and Kyma are supported, but it's also flexible. We can support arbitrary other contexts because cloud logging allows to ingest data via public API or an open API, and therefore you can ingest data, for example, from your build pipeline if you want to have build logs or build execution success, or from other systems that you have in your environment. So it's really open in that sense. And last but not least, quite important piece is cloud logging can be used both locally for your application context, but also supports remote usage, which means you can ingest data from not just a single application, but multiple applications, also multiple contexts, so sub-accounts or global accounts, multiple data centers, or even regions. So in that sense, it can really be a nice unifier of data collected from different locations. Data ingestion, now how to get data into cloud logging concretely. So the first, we continue to support the traditional log ingestion via the Cloud Foundry runtime. So you simply bind cloud logging as logging service to your application, and then logs get immediately streamed to application logging. It's the same approach that you might know from application logging service. We have on top some support libraries that simplify the instrumentation for you for Java and Node.js, and all the details are well described in our help portal. For Kyma, there's already built into Kyma directly the shipment for logs, metrics, and traces, which relies on the OpenTelemetry protocol. So far, for metrics, traces, logs is still in a traditional JSON-based format, but also there, the switch to OpenTelemetry is in the last phase of its development or delivery. Again, well, documentation in help and Kyma documentation. And last but not least, generic ingest protocol is this so-called OpenTelemetry. which you can use already also from Cloud Foundry runtimes, from different programming languages, contexts, whatever. And there you get the full support for all logs, metrics, traces. And again, we describe it here. Perhaps just one note now on OpenTelemetry, because I mentioned that so often. And just in case you've never heard about it before. So what is OpenTelemetry and why should you care about it? OpenTelemetry is an emerging standard for dealing with observability data. And what makes it shine or important is that it is vendor and tool neutral. So it supports, already mentioned, logs, metrics, traces, and has a very well-growing community and support across all kinds of different languages, libraries, and frameworks. And in that sense, it's really smart to look into that, because that gives you a sustainable invest into your observability instrumentation and transportation strategy without lock-in. And that's also why we, SAP, really invest heavily into that direction. Now, when it gets suppose you have ingested your data, then you can do analysis. I will show much more of the details here in the demo, but just to show you the welcome page that Cloud Logging offers. So it gives you direct links. So if you have how to ship the data, but then to access so-called Cloud Foundry dashboards or Kima dashboards, OpenTelemetry dashboards, the so-called observability plugin or tab to do trace analysis, and many, many other information. More details to come in the demo. Let me go a bit deeper on some aspects which are very, very new in Cloud Logging compared to application logging, or where Cloud Logging shines the most. Let's phrase it that way. Tracing is the first one. So Cloud Logging comes with trace analytics. It's based on OpenTelemetry and part of a so-called observability module. And here on the right-hand side, you see some of the powerful insights you can gain with tracing. So on the top, you see a service map, so which can visualize how the different services you have or microservices interact with each other. On the right-hand side, you see the trace span analysis, so how an overall trace breaks down into subcalls and how this evolves over time. So then you can really see the efficiency and execution chain of such a call or trace. And last but not least, we also built pre-built dashboards to correlate now traces with general log messages simply based on trace ID, which is used to correlate the information. So that's tracing. Second, pretty important and new feature, alerting. Cloud Logging comes with a built-in feature for alerting. And actually, alerts can be triggered on arbitrary observability data. So whatever you have in there, you can use it for alerting. There are the usual concepts for alerts based on a monitor, then a trigger, an action that shall be executed, and a destination. But also there's a UI-based support to set up your alerts in a convenient way. And eventually then you can send your alerts to either a webhook or a Slack channel. You may feel this is a bit limited, but actually SAP has this nice alert notification service, which offers a great variety of alert destinations. And that's our recommended way. If you need other destinations, connect via webhook to alert notification service. And then from there, you can filter, slice, dice, but also dispatch to arbitrary destinations. One positioning statement, the alerting here is rather meant for local technical alert scenarios. If you have really central alerting, which matters across your entire portfolio, this is rather a topic to address in the Cloud ALM solution. Then there's one thing I would like to dig deeper a little bit, is this mentioning of OpenSearch. So I already indicated that OpenSearch is a key component powering Cloud Logging. It is actually an open source successor of something you might have heard of as Elastic Kibana. Elastic Kibana used to be a successful open source solution, or kind of, but then changed license to become more viral. So for us, it's no more usable. And at that point in time, roughly 3 years ago, an open source successor was coined, called OpenSearch, which in the meantime became a super vibrant and active community. and even now is hosted by a foundation under Linux Foundation. And we from SAP felt this initiative is so important that we also joined that foundation as a premium member, just to best possibly support that super exciting, innovative, and fast advancing software stack. This OpenSearch thing comes with a bit of new terminology. So we call it OpenSearch then, and OpenSearch dashboards. So these are the prime terms: OpenSearch, the overall stack, and dashboards, basically the front end. And what we now do from Cloud Logging, we deploy a dedicated OpenSearch cluster for each service instance. So which means each customer creating a service instance gets a highly isolated environment, which they can really adjust to their needs. So that's a very, very powerful and flexible baseline then that you have. And with that, we can enable many of the features from OpenSearch, not all of them for various reasons, but most of them. For documenting all this, we kindly refer to the OpenSearch documentation. It doesn't make sense to replicate all this. And then last thing, with OpenSearch comes OpenSearch dashboards, which is the front-end data visualization, data exploration technology, which offers a variety of query expressions, charting types, and more. On the right-hand side, you see a snapshot from the official OpenSearch dashboards documentation, and you get already a glimpse how powerful the visualization techniques are in there. Again, we deploy OpenSearch dashboards for each of our customer instances to give the full flexibility and variety to you, and have it well integrated into the overall documentation strategy. So that was basically the overview. Now let's go a bit deeper. How you can now observe your BTP workloads. And for this part, I will mainly do it via demo. Just to show you a little bit the storyline. Actually, this is the landing page. We will see it in a second. And basically, the flow of the demo goes pretty much along the different sections of this landing page. So you have a link to the online help, then from there can show how to do Cloud Foundry application analysis with its dashboards, how to do slicing and dicing with different techniques. Then we can look into OpenTelemetry, what kind of additional data comes relevant with that. We will look deeper into custom dashboards, how to build your own dashboards from scratch, or by relying or copying an existing one. And hopefully we also get to the discovery node, where you see at the core the raw data, which is also sometimes nice for deep analysis. So that's the menu for the demo part. Let me go here. So as said, that's our landing page of Cloud Logging. Let me change here the time frame a little bit. So that's where you get started, and then you can, for example, here have links to documentation. So if you click on that piece, you directly end up in Help Portal and see, okay, how can I ingest from Cloud Foundry, Schema, or other contexts? So that's very easy. But now let's go deeper to a Cloud Foundry dashboards. So that's here, this section. So if you click on that, you end up in a Cloud Foundry overview dashboard. Users of application logging know this already to a good degree. So it gives you top-level insights about your Cloud Foundry applications. On the left-hand side, you see a so-called request overview, which basically is all your access logs, be it HTTP requests and the like. So you see that over time. You get some high-level metrics such as success ratio or average response times, number of requests per second. And you also see which of your applications contribute here to the overall load. On the right-hand side, you see the actual application logs. So these are the logs that your developers have emitted by having really added a log statement to their coding. And typically log messages come with a log level and some information about the underlying logger. Again, you see the evolution over time and the applications which contribute to that. And then below this dashboard, we offer so-called drill down capabilities, because at the moment, what you see here is everything that is ingested. But this, for example, different applications or components contribute here to the load. So you see here, roughly 8 different components. You see to which Cloud Foundry space they belong to which Cloud Foundry organization they belong to. And then what you can do, for example, for whatever reason, I'm interested in this Java incident processing. And then the easy thing is you just click here on the small plus symbol. And with that, you create a filter, which is shown here on the top. I hope you can see that here, the filter. And then all of the rest of the dashboards adapt accordingly. So now you only see requests from that application, nothing more. And then you can for sure drill into a certain time interval. Say, okay, around 3 a.m. there was something fishy. So you filter that and then get the details for that time frame. Right? So that's already the very first glimpse how you can do slicing and dicing in OpenSearch dashboards. So let's move back to our original view. So that's just the overview dashboard. Now you can go deeper. Here's a simple one which just gives top-level indicators for your mainly used applications, again with some success criteria, response time, statistics, etc. Not that big of a deal. Here it becomes more interesting. The 4 golden signals. 4 golden signals, that's a methodology. It was coined by Google, but it is widely adopted actually. It basically says, if you only observe 4 signals of your application, you don't have capacity to observe more. These 4 signals are the ones you shall watch out for. The first is the latency. So really how well your application serves requests, right? How quick. The second is the traffic, to understand how many of those requests do you get. So what's the load from the customer? The third perspective are the errors. So how often do errors occur in your response? And the last is the saturation. To which degree is your application saturated? Because if it's highly saturated, there's a risk. If the load further increases, then you might no more be able to serve the customer. And this is something now which is based on the Cloud Foundry log messages. Here as a top-level overview, but then we also have more detailed dashboards for all of these. For example, with latency, if you want to really understand latency better and not just broad average or worst case, you should look into a bit of statistics. So basically the percentiles of latencies and how they look like. And this is an example dashboard that really can help you to understand those patterns deeper. So far about 4 golden signals. We have another dashboard about usage. If you want to understand how is your application used? So by which HTTP methods, but also by which distribution paths you see here on the left-hand side. And again, you could filter on a certain component. So let's again take this Java incident processing here. If you filter on that, then immediately the targets apply as well, right? Adapt as well. And then you can dig deeper. How often are the different endpoints invoked here? Performance and stability is yet another thing, dashboard, which basically brings key quality indicators, status codes, and response times together. History can be a nice thing to understand how your application evolved over time, again, in terms of percentiles and statistical data. But there's also one more sophisticated thing. It's the so-called minimum cumulative success ratio. So that's a dashboard. I hope it comes up in a second. Yeah, here we are. And if you want to understand service level agreements, things are not as trivial as they may sound at the beginning. So with minimum, it actually depends on how you count success. Is it a count-based measure or is it a time-based measure? And if either or, what's the time frame or the window size you look at it? So this is a dashboard which shows the continuity of these different values or settings you can have. You see success ratios based on count, based on time, along window sizes. And then you can also change the window size in here and then see on the right-hand side the impact on the actual success ratios over time. That's under history. Now let's go back to the more general things. Requests and logs. Another pretty important dashboard. So you have HTTP requests. So for example, post request. Here at the top, further down, you have actual log messages. And then it could well happen that at times you want to understand, okay, here, for example, this log message, under which context, under which request was it invoked? And then you click here and filter on the trace ID. And then basically you see all the HTTP requests that come with this trace ID. So it's a great mechanism. Sorry, here's other ones to correlate traces or requests with application logs. Further down, there's another interesting piece, which are the so-called runtime logs. So the Cloud Foundry runtime issues log messages. So for example, that a certain cell, so that's the virtual container, has been destroyed and is recreated. Or we have here that an application instance was terminated with some information about that termination, or a process crash happened. So this could also come quite handy in order to understand what happened to your application as an overall piece. That's the request and logs. And last but not least, there's a dedicated dashboard which we added recently. It's about crash events of applications. Because you know, in the cloud, crashes happen, right? It's designed, but applications shall restart and shall be distributed among multiple instances. So this charting here shows the crashes that happened and gives also indicators about the reason for crashes, whether out of memory situation happened or some other general crash happened. So shall also give good insight. That's the Cloud Foundry view of things. We have basically the very same dashboards for the schema context. Just in this demonstrator, I don't have data for this, but you see here again, overview, for golden signals, usage, requests, and logs. So basically the very same things you can do for your schema applications. Now let's go to OpenTelemetry. For OpenTelemetry, there's a dedicated plugin here. It will merge to a dashboard in the future, but so far it's a dedicated plugin. So this really helps you to understand traces in your system. So if we, for example, here have a post request, which has been issued, and then look, oh no, here's the one I wanted to look at. Here's the post request. Okay, that it shows very nicely the breakdown, how this request was handled first by an API service, then a database upsert statement has been executed. Here an OData call has been added, and so on and so forth. So that's a really powerful thing to understand, how your application behaves on an individual request. So that's one of the great advancements which come with OpenTelemetry actually. And then the second thing I wanted to show you, let's go here perhaps. We also have dedicated dashboards for OpenTelemetry. The first one we see here supports the correlation of traces and log messages. So again, here, if I click on a log message, I see the relating overall trace message, hopefully above. No, in this case, there is none because it comes without a trace context here, but for others, there would be. And then next to this, you see metric support. As said, OpenTelemetry doesn't only support logs and traces, but also metrics. And what we have here, created here, is a so-called Metrics Explorer. This guy, or this dashboard is the first dashboard you can use to see, okay, what's the overall set of metrics I have? Because just by instrumenting your application with OpenTelemetry, you get many metrics for free. And here you have a Metrics Explorer where you can see all kinds of metrics from disk usage, JVM memory, and the like. You see some raw data about these, and you see already some preliminary or some example visualizations. So a gorge-based visualization, or a sum-based visualization, or an aggregation visualization. So already to help you to look at these different metrics, to see how they can be visualized, And with that, then to build your own dashboards on those metrics which are most meaningful for you. We have here, for example, also built a pre-built dashboard for JVM metrics, which shows us stuff about memory and garbage collection and CPU consumption and stuff like that, but this is more exemplary nature so far. So that's the part on dashboarding analytics. The last thing I want to show you is how to create now own visualizations. Because, yeah, for example, you have a new metric and then you want to do that, right? So here's now the tool. So this all happens within the UI, right? No programming is needed. So you say, I want to create a new visualization. Let's say it shall be a metric. I want to have a visualization on how the response time of my application evolves. So for such metrics, there's a visualization type, TSVB. And then you click on that and already see how this visualization would look like with some default settings. But actually, we don't want to have the default settings because we said we wanted to look at response times. And let's say we want here. So now I have to select the field, which is basically then the response time in milliseconds. And now we already see here above how the visualization looks like. We might, one thing is aggregation count makes no sense. We should set it to max. So in this chart now we want to see the worst response time we have observed over a certain amount of time. Hope that, no, now I did a mistake. My fault. Let's go back. Here it's the aggregation that we want to change. Now we see the response time. Nice. And now what we can do, we want to save this visualization and say, yeah, it's a new custom visualization on response time. Save. And in a second, we have created a new one. So now let's go back to our dashboards. Let's suppose the following scenario. You've been here using the pre-built dashboards, let's say a usage dashboard, and you saw here a visualization, total request rates. Sounds interesting, but now you realize, well, actually I have a multi-tenant application. I would like to see such a dashboard, but with a differentiation per tenant, right? So then what you can do is, again, let's go to the visualization. Here, and let's search among the existing dashboards for the one that we have seen, total requests, the TSVB. So that's the aggregation we've just seen here, right? And now what we want to do, we want to add a grouping. Not everything together, but having a grouping by terms. And in this case now we say it's the tenant ID keyword. With that, we already see here above, now we get a visualization which basically shows us currently for two known tenants, named tenants, and an unnamed tenant, the third one, the other case, how the visualization adapts. So again, we can save this. It's a new visualization because we don't want to overwrite it, right? It's now the custom total requests, TSVB. So with that now, we have a second visualization. And last step now, we want to compose a dashboard out of those two things. So we are here in the dashboard section and say we want to create a new dashboard. And to that one, we just add an existing visualization. So let's first here, the response time thing we did a few seconds ago. We already see it. And then we can add a second visualization. The tenant-specific request situation. And with that, now the only thing that remains, we save this, have a new custom dashboard. And with that, you created your own visual dashboard with two visualizations, one created from scratch, and the second by relying on an existing one and modifying it further. Now, that was the end of the demo part. Sorry, it was a bit long, but hopefully insightful for you. Let's move back to the presentation part. Here again. In the slides, you will also find indicators how to do these customized visualizations, kind of step-by-step guide. But now let's go to another topic. I already mentioned application logging used to be there for a couple of years, and now we have cloud logging. And I want to take you on the journey from the first to the latter. So why did we invent cloud logging in the first place? The reason is to address the top 10 requirements we got from you over the last years. And those are now addressed with cloud logging, and therefore we can now support things like alerting, custom dashboards, configure retentions, and many, many more things. And this is only possible because we give each customer or each instance a dedicated OpenSearch stack. Only with that, we have the isolation and the flexibility to give you all these nice features. Now with cloud logging, it's generally available since more than a year now, and since then really proved itself to be proven and stable service offering, which made us confident now to do the next step to start the deprecation of application logging. So this was announced beginning of the year in Discovery Center. And the impact basically is that as of August this year, new customer contracts can no more purchase application logging. However, existing contracts can for sure still use the service till the very end of their contract period. To support now the transition from application logging to cloud logging, we provided two guides. First is the Service Innovation Guide, which basically explains in detail why we innovated, why we deprecate application logging, and then gives you detailed insight on the new capabilities or the difference that are there between the two ones, and gives good guidance how to plan for nice proper service deployment, how to make use of the available service plans, how to understand the pricing, to do sizing, instance planning, and all this stuff. And second, we have a so-called Service Migration Guide. It's a very short, straightforward 6-step procedure, which allows you to introduce or describes how to introduce cloud logging in a side-by-side setup, and with that, to go into a very smooth transition. For the sake of time, I will go through this now relatively quick. Here, a feature comparison between application and cloud logging. Basically, you see on the right-hand side, all the features from application logging are still in cloud logging, but there are many, many more. Let me just point to two differences. So the first one is here further down. It's the authentication mechanism. In application logging, authentication was done by a Cloud Foundry or UAA. In cloud logging, this is no more appropriate because cloud logging is generalized. It's not only for Cloud Foundry, but for many environments. Therefore, we went for a SAML-based authentication or authorization model together with an IDP. And last mention here is there's one small feature gap still in cloud logging, which is the support for Cloud Foundry container metrics. This is close to be finished in its development and shall be delivered very soon, early in this next quarter, Q2. Here, a short glimpse on the migration guide, or how to migrate from cloud logging to application logging. So basically, the procedure is very simple. You set up cloud logging side by side, let your data flow simultaneously into both application and cloud logging. And once you are satisfied, you can change perhaps the observability procedures you have on top of cloud logging towards cloud logging, and then simply shut down application logging. So this is basically described in the guide. We have also visual diagrams that explain this in more depth. There's just one thing. For cloud logging, you can for sure have a single cloud logging instance for wherever you had an application logging instance before. So that's the most straightforward case. But you could even try to combine different application logging instance into one cloud logging instance. Service plans. Okay, also that's quite different and in some degree way more powerful. So the production plans we offer in cloud logging are way more powerful in terms of capacity. So we have two plans, standard and large, and they give you net storage capacity between 75 gigabytes up to 3.7 terabytes. The interesting thing is that the service instance can scale automatically within configured limits. which means the instance have auto-scaling along the load that you put into the system. And we have two parameters there. One is the max data nodes, which is basically the maximum storage you can give. It's powered by the number of so-called OpenSearch data nodes. And the second is the max number of instances, which basically gives the number of ingest instances, again, which are scaled. If your ingest increases dramatically, more instances will be provisioned. If ingest decreases, they will be deprovisioned. So it's auto-scaling in both directions always. Second thing is data retention and curation is way more flexible. In application logging, it was always 7 days. In cloud logging, you can configure the retention period, so the time until ingested data shall be deleted. And then the curation is based on two things, the time that you specify and the disk utilization. So time is obvious. The second thing is if the disk usage has exceeded its watermark, then and the instance is already scaled out to its maximum, then the system will automatically delete older indices. Last, we have a development plan called dev, and also that's also the one which is promoted in so-called build code context. It offers all the functional features that cloud logging comes with, but it's planned only or foreseen for evaluation purposes, so it shall not be used in production use cases. And the reason for that guidance is simply because it lacks cloud qualities. It doesn't have any data replication, it has no auto-scaling, it doesn't react to changing ingest, it has very limited ingest throughput, it has no high availability. So it's really there to evaluate the functions, but not to use it in production. But it's way cheaper than the production plans, and that's why it has a right to be there. Metering and pricing, also a bit different. Application logging had a very fixed t-shirt size-based pricing per month. In cloud logging, the metering and pricing is based on the provision components. So you saw that with the auto-scaling, right? You always need a foundation, but then the storage scales between 2 and 10 nodes, same as ingestion. So this needs to be properly metered. We do that at hourly level, and then aggregate all these information into a single metric, which is called the capacity units to understand then the eventual price. We created a dedicated, check that I can quickly show you this. We created a small pricing calculator for this thing. Let's open that one. So it works relatively straightforward. You change the desired service plan. For dev, everything is fixed, no flexibility. So you need 95 capacity units. For standard, for example, you see here, you can configure the upper limit or the limit, how many data nodes you want to have, how many ingest nodes you have. And depending on that configuration, you see that the total capacity units change. And there's also one parameter to enable OpenTelemetry or not, because that requires a dedicated provisioning component. So back to our slides. So it sounds in the first place a bit more complex, but the benefits of this approach, are really relevant, because on the one hand, it's an accurate metering. It gives you cost planning safety, because with the service plans and the upper bounds, you have costs under control, but at the same point in time gives you the flexibility if your observability load changes over time. One also relevant thing, if you think about cloud logging, to have to consider the sizing. How much do you need? How much volume? Here you see in our innovation guide, one table, it's copied from there. It simply explains the difference. With the application logging, you have the 3 service plans super fixed with their ingest quota per hour, and then the maximum effective storage. This is only a very theoretical value, because you can only reach it if you have a steady load across the whole time. So in most cases, you will see way less. In cloud logging, this is completely different. We don't put any quota in there. The only limit is, so to say, the amount of hardware that we provision for you. which in this case then here is the effective storage we provision for you. And if you have, let's say, low ingest at a certain point in time and then future growth, you basically can reuse storage gains from that evolution. However, you should not just take sizing and into account when planning cloud logging. You can also think about overall costs. If you have shared instances, of course, they are more cost effective, but you might also consider legal and operational aspects, which might in some cases dictate you to run dedicated instances. For example, have different instances for production workload or development workload, or have different instances for legal regions that you have. For sure, cloud logging comes with security features, interesting security features. So you can restrict access to data on index level or on document level based on roles. So this can help in some cases, but nevertheless, there might be also cases which really dictate to run dedicated cloud logging instances. And last but not least, you might consider the need for having shared analytics. Of course, if you put things into a common service, you can do shared analytics across all the data in there. One important note is if you have different cloud logging service instances, you cannot analyze data across those. This is a feature which might come in future, but we don't have it clearly have a clear date for its delivery yet. So with that, we are getting towards the end of the session. Just the main summary that I hope I was able to transport here. So SAP Cloud Logging offers in-depth observability or monitoring capabilities for BTP workloads, in particular Cloud Foundry and schema-based workloads. Cloud Logging is an integral part of the BTP developer guide and is mainly supporting is the observability support for CAP-based applications. And last but not least, it's well integrated and also comes with a common instrumentation and navigation approach together with Cloud ALM, so that you can go from central problem detection in Cloud ALM to problem resolution in Cloud Logging. And last but not least, when you want to go from SAP application logging to Cloud Logging, just get this notion. Cloud Logging is the next generation solution across all the main customer requirements. So we will not do new innovation in application logging anymore. You have service innovation guides with clear comparison and usage guidance. You have service migration guide, which offers a clear migration path. And hopefully with that, we can serve your questions. If you need further information, here are the main links. Cloud Logging in the Discovery Center, the two mentioned guides, and other than that, approach us via the support channels as needed. And with that, I'm done. We are at the end of today's session about cloud logging. Just an outlook to the next session, which is to come in the series, is on April 3. There you will learn about operation automation with Cloud ALM and how to do this in the best possible manner. And with that, thanks a lot and looking forward to questions.
Great, thank you so much. Could you perhaps unshare? Then people can see us bigger. Great, thank you so much. Thank you so much for your excellent presentation. And let us come straight to the questions. First one is, does it also, that was relatively to the beginning, does it also support audit events like user creation, deletion on sub-accounts, org level?
No, please don't use Cloud Logging for audit events. For audit events, they have legally binding relevance. For that, SAP is offering a dedicated service called the Audit Log service. Cloud Logging is for technical log messages to analyze workloads.
Great, thank you. Then the next one, is there a chance that SAP will connect internal data intelligent Kubernetes to this environment for customers? Customers do not have option to connect it as Kubernetes is managed by SAP.
That's a tough question. I don't want to talk about the roadmap of data intelligence there. For sure, connection. We have many cases where workloads deployed on Kubernetes are instrumented and propagate observability data to Cloud Logging. So in principle, technically, this is possible. We have to check with the respective team, in this case, then the data intelligence team, how they can do this, in particular, probably satisfying tenancy requirements, because I assume with that question comes the case you have a multi-tenant solution and you only want to have propagated the data of your own tenant into your own Cloud Logging instance. It's a common requirement. It could be solved with data intelligence. We have to engage with the team then.
Thank you. And currently, last question is Cloud Logging the best BTP tool to be used to set up alerts for integration suite iFlows, or is ALM better positioned?
Sorry, for which solution? For integration suite?
Yeah. To set up alerts for integration suite
to be
iFlows.
Honest, I'm not that well familiar with integration suite. A typical guidance, so if you have an alert, you want to react to something that you have observed, right? If you have the observations available in Cloud ALM, then you should do the alerting in Cloud ALM. I guess that's the general right. If possible, you do it in Cloud ALM. But there are many cases, I cannot show whether it's the case for integration suite, where Cloud Logging has more detailed information. And then if you want to base an alert on those details, then triggering the alert from Cloud Logging is the way to go.
Thank you.
You're welcome.
Then last question currently is any pointer on how to handle or implement observability for SAP UI5 or Fiori applications?
Okay. Oh, that's an interesting question, or a good question, to be honest. We don't yet have implemented cases for that. In general, I would assume that Cloud ALM comes also with, to some degree, user experience monitoring, right? But to be honest, I'm not fully familiar with that either. So I cannot exactly say. At the moment, we don't have cases for that. As soon as we have it, we will publish it on the help documentation, because that would require also guidance how to set it up, right? So as soon as we have it, we will publish it there and then make it known.
Thank you.
You're welcome.
Does Cloud Logging support ABAP environment?
Well, it can be used from arbitrary environments, because Cloud Logging is, so to say, a backend which has an open API. And if that other environment, whatever it is, can basically make an HTTP call to our backend, and with that HTTP call transport data to us, it can be integrated. In that sense, we are fully open to arbitrary environments. But as of today, we don't have pre-built dashboards or stuff like that for environments other than Cloud Foundry, Kima, or generic OpenTelemetry-based instrumentations.
Thank you. Next one is, are there any AI features included in Cloud Logging?
Sorry, AI features, you said?
Yes.
There's the anomaly detection included in Cloud Logging. I don't want to engage in the controversy whether this is considered AI or not. Some people say yes, some people say no. But at least that's in the observability space a typical pattern, right? You don't have a specific threshold known in advance, but tell your observability solution, yes, if something seems to become unnormal, please notify me. So that's anomaly detection. And that's part of Cloud Logging and OpenSearch actually, yes.
Thank you. Costing will go on as per the usage-based. In this scenario, how can we track usage limit?
Okay, there is one dashboard I could have shown. I guess we are almost out of time. So the dashboards of Cloud Logging come with a dedicated tile called service. And there you can see your current usage of Cloud Logging, to which degree your storage volume is already consumed, to which degree you have still empty free space available, to which degree you already scaled out or scaled in along the data nodes. So this is all built into the dashboards that we have so that you get those insights there.
Thank you. Is one instance of Cloud Logging enough for monitoring apps deployed across different SAP accounts environments?
It all depends on the load that the applications create. So the bounding factor is not the number of applications that you bind with Cloud Logging, but the amount of observability data that you ship and want to store in Cloud Logging.
Great, thank you. So that is currently the last question. Once again, as usual, if you have any questions popping up after the session is over, please post them in the comments area underneath this video. We will look at them and Wolfgang will be happy to answer them.
Sure.
And with this, I would also like to thank our angel working in the background, Boris Tarska, for posting links in the chat. And with this, a big thank you again, Wolfgang, for your excellent presentation, for answering all the questions, and a big thanks to our attendees for joining us. I hope you got a lot of value from the session, and I hope to see you again next week. Have a great evening, a great day, depending on where you are. Bye-bye.
Bye-bye. Thank you.